Welcome everyone to session 7 of the TLS series. Let's continue our discussion on certificates, starting with some good to know terminology. Certificate Authority or Root CA. This entity signs certificates for other entities. So how do we know for sure that a certificate is a root CA or not? The issuer and the subject fields are the same. The key usage field has a key cert sign set, or the basic constraints field has the CA attribute set to true. If you're looking at a chain certificate, which we will discuss shortly, the topmost in the chain is the root CA. But there is an exception to this as per RFC 4210, that the certificate authority decides whether to use intermediate certificates, which may also be at the topmost location in a chain. Subordinate CA or intermediate CA. This could be any CA which also signs certificates but still is under the control of the root CA. A certificate bundle. This indicates that more than one certificate is concatenated into a single file. Usually this is in a PEM format or .pfx. The end entity certificate. This entity cannot sign other certificates. This is usually the last in a chain of certificates, and it represents the actual device or entity that has enrolled for a certificate from the root or the intermediate CA. There is another term called EV certificates, but this is not in the scope of this discussion. You can still identify this type by looking for a certificate policies extension. This will contain a registered OID or object identifier in the policy identifier field. Now, as we have an idea about most of the terms in a certificate, we can move to the discussion about certificate chaining, which is very important. To start with, not all certificates are chained. A certificate may be signed by one or more intermediate certificate authorities or by the root CA directly. Relating to the actual TLS discussion that we are having, when an entity certificate or a bundle is obtained from a server by the client during a TLS handshake process, it must be verified by the receiving software and all the way to the top by the root CA, including all intermediate certificates if included. Please refer to RFC 5280 regarding details on all certificate fields. This RFC also has details on the topic of CRLs, also called Certificate Revocation Lists, but we will try to understand the basics of CRLs over here as well. CRLs or Certificate Revocation Lists are a method by which certificates may be invalidated before their not after date has expired. In simpler words, if the expiry date of the certificate has come upon, the certificate is anyway invalid. However, even before the expiry, if a certificate needs to be invalidated, it will be added to a CRL. These lists are provided by the CA who signed that certificate. CRL checks are done when a certificate is received from a server or a client for verification. Many systems rely on CRL caches and per certificate checks are not performed. To handle this, caches need to be updated frequently to maintain security. The CRL has a list of serial numbers, and these numbers identify the revoked certificates. Before we end this session, let's get to know about certificate file formats. Natively, all certificates are DER encoded, which is an 8-bit binary encoding. You will have to look up 8-bit binary encoding if you don't know what that means. If there are multiple objects within the same file, you might hear the terms PKCS7, PKCS8, PKCS12. X509 is another format, which is base64 encoded with extensions such as .cer or .crt. If a private key is also included in a certificate, they appear as .p12 or .pkx. CSR is a term used for a certificate request file, which is not a certificate but contains info required to generate a certificate. Here is a tip: if you open a certificate in a text editor and can't make sense of whether it is a certificate or not, it's DER encoded. That's pretty simple. On the other hand, if you see the file content and it starts with begin, then it is base64 encoded. CRL is for certificate revocation lists and PEM is for chain certificates. Here is where we end the discussion of certificates. With that, we also come to the end of the TLS series. Hope you guys enjoyed it and learned some new stuff. Like the page to follow up on regular updates. Share the page because someone out there is still looking for this. Get in touch if you have any questions. See you all in the next interesting discussion. Happy learning.